lesson we are going to continue from yesterday's one. So today we'll be doing 7.2 estimating probability. So here there are few theories that you need to understand, but before that let's just go to the basic questions to understand how good are you at solving these before we move on to the theory. Right, so for question 1, part A, can somebody tell me the answer?
20.
1 upon 4 multiplied by 60.
Is it 240?
How do you find the answer? 1 upon 4 is a fraction there multiplied by a whole number here. So how do you do it? 1 upon 4 multiplied by 60. So this actually equals to 60 divided by 4. What is the answer?
20 answers.
15. Similarly, can you tell me the answer for B? Yeah, B is 3 upon 5 multiplied by 200.
So the answer is 120.
Let's see. What did you get?
I got 600 divided by 1000.
600 here. No, that's wrong. So here, see, this equals to 3 multiplied by 200, which is 600, divided by 5. Right? So for 60, how many 5s are there?
120.
12 5s are there for 60, right? And then there's a 0, so you can put 120. So the answer for B is 120. For question 3, it's 7 upon 10 multiplied by 150.
Equals 105.
105, right? What is your answer?
105.
Okay, so how do we do it? Now if any number we have to divide by 10, and if there's any 0 on top, you can straight away cut it. So you don't need to multiply this whole thing again, divide it by 10, and don't waste the time. So if there's a 0 on top, 0 down, you can just cut it out. And 7 times 15, it's 105. Is that clear?
Yes.
Right, so those are the basic ones. You have to know how to do the calculations. Right, now let's move on to question 2 and see if you can get the answers there. Convert these fractions to percentages. Have you done those questions?
Yes.
So to find a percentage equals to the fraction multiplied by 100%, right? So now in this one, see, 37 for A divided by 100. This is the fraction. So to find the percentage, we multiply it by 100. This 100 and this 100 gets cancelled. So you get the 37%. Is it clear?
Yes.
Then for this one, second one you can write 18 upon 40 multiplied by 100. You need to find this now percentage. So how many so what's the value here? 1 0 we can cut from here. Then how many 2's are there in 10? Here 5, here 2, and here I can divide this by 2 again, and here 1. So 9 times 5 is 45%. Is that clear? Right. Now for the last one, there is a bit of calculation. So let's see how we can do it. So always remember, if you have any kind of fractions, just try to get the simplest form. Then it's easy for you to do the calculation. Right. For the third one, 38 upon 250. Right. I'm going to find the percentage here. So 1 0 and 1 0 I'm going to cut here. Right. So for 25, how many 5's are there? It's 5. Here there is 2. So 38 times 2 is how much? It's going to be 6. (76) divided by 5. So how do you find 76 divided by 5? 5 times how much? 1, 2 remaining. You get the 6 here. These are basic things you need to know. One remains, and we need to get another 0 here. Then we put a decimal point here, and for 10 there are 2. So the answer is 15.2%. Is this clear?
Yes.
Okay. Right. Okay. Next part, there is a small theory you need to learn in this. So yesterday we did about experimental probability, and today we are doing about relative frequency. We are going to learn about this now. Right? Now under estimating probability, we are going to learn about relative frequency. So let's see what is it. For a set of data, the relative frequency, this is bold because you should know this term. Now this is what you are going to learn here. Relative frequency of a value equals frequency of the value divided by the total frequency. You can calculate the expected frequency of a value in a larger set of data. Right? So let's see some examples here. Some year 8 students were asked which device they used to access the internet. And then they are asking you to calculate the relative frequencies. So let's see the data they have given. You can see there are 3 devices: smartphone, tablet and computer. And the frequencies for each gadget is given here. Each device is given here. Right? One thing you can do is calculate the total frequency first. So here you can see you have to add all the frequencies to find the total. Once you find it, you can calculate the relative frequency. Relative frequency equals frequency of the smartphones, that is 10 here, right? Divided by the total frequency. What is the total frequency? 50. So 10 divided by 50 will give you the relative frequency of the smartphone. Is it clear? Same way for the tablet, the relative frequency equals to the frequency of using the tablet. 18 divided by the total total frequency, which will give you the answer as 18 upon 50 for the relative frequency of the tablet. Clear?
Yes.
Compute also same. So frequency of the computer is 22. Total frequency is 50. So 22 divided by 50 is equal to the relative frequency of the computer. Is that clear?
Yes.
So here they are telling you to calculate the relative frequencies. So these are the relative frequencies. Did you understand how to calculate that?
Yes.
Right. Now then there's another one. There are 200 students in year 8 altogether. How many would you expect to use a smartphone? Now this frequency, when you calculated all together, when you added all together, you got 50. So this is the frequencies they have given you, the data given for 50 students only, right? But now they are asking for how many? 200. So using the details you have here, considering the relative frequencies you have here, you have to find now for 200 students and see how many are we expecting to use a smartphone, right? So using the given data here for a smaller set, we are going to find the expected results for a bigger set. So then how do you do? For a smartphone, what is the relative frequency? 10 upon 50 multiplied by the number of students you need to find now for 200. So that equals to 40. So you can say you can expect 10 upon 50 of the 200 students to use a smartphone. So when you write the answer, you can say I expect 40 students to use a smartphone. This is how you use the relative frequency to find an expected result for a bigger set of data. So moving on to question 3, there is a similar type of question just like the worked example there. So you just have to calculate the relative frequencies first. Calculate the total frequency first, then calculate the relative frequencies, and then find the expected results or expected number using the given relative frequencies, right? Let's see one by one. Work out the total frequency. What's the total frequency? Add these three together, you get 100. Now once you find the total frequency, you can find the relative frequency. So here it's going to be 75 upon 100. Here it's going to be 20 upon 100. Here it's going to be 5 upon 100. Right. A further 300 people received the treatment. How many would you expect to have improved eyesight? So now this is the trick here. Improved eyesight, when say, it could be great or slight. Because both cases it showed an improvement. So you need to take both cases here. Because this says same over. So there is no improvement at all. But here they say great improvement and slight improvement. So you need to take both situations. So 75 plus 20 is 95 out of 100. That's the total frequency. And then here 300 people. So you can find the answer for D like this. So here, like I said, you can cut these two and these two. 95 times 3 is 285. Did you all get the answer?
Yes.
Okay. Right, so question 4. In a survey, 200 households, 65 have high-speed broadband. There are 1,000 households in a village. How many would you expect to have high-speed broadband? Okay, Now we have to find the relative frequency of having high speed broadband. Yes, now what is the frequency of having high speed broadband? 65 out of, what's the total frequency? 200. This is the relative frequency of having high speed broadband. Now if there are 1000 households in a village, you have to multiply this by 1000, right? So here you have 5 200s, here you have 1. 65 times 5 equals to, yes, answer is 325. This is A. B. How do you do B? 40 parents attended a school meeting, right? Now how many has attended? 40. 40 is the total frequency now. 27 said they preferred to have 4 school terms. Now out of the 40 parents attended, 27 is the frequency who preferred to have 4 school terms. Now if they are saying if 600 parents have children at school, how many would you expect to prefer 4 school terms? Now if this is the frequency for 40, what will be the frequency? This is a relative frequency here. So what will be the expected results for 600 using the relative frequency of the preferred parents who chose to have 4 school terms? So here you can cut down 1 0. Here it's 15 and here it's 1. What is the answer? Answer is 405. Okay, so for this question they have mentioned the calculator, so you are allowed to use it. I hope these explanations are clear. This doesn't have much, but you just have to understand the theory, the simple theory of how to find the relative frequency, and then how are you going to calculate it for a larger group using the relative frequencies. Right, now question 5. For question 5 it says, restaurant owner Maurice recorded the number of seats reserved for each booking during a week. Now for 2 seats frequency is 30, for 3 seats it's 10, 4 seats it's 25, 5 seats it's 5, 6 seats it's 10. What is the total frequency?
80.
30 plus 10 is 40, 40 and 30 is 70. Yes, we have 80. Total frequency 80, right? Okay. Right. Here what's the value? What's the frequency?
30 upon 80.
Yeah, here you can say 30 upon 80. Next one.
Next one, 10 upon 80.
Yeah, it's 10 upon 80. Next answer, 25 upon 80. Okay, sorry, 25 upon 80. Yes, next, 5 upon 80 and 10 upon 80. These are the relative frequencies. Is it clear?
Yes.
Right. So they ask you to copy and complete the table. Estimate the probability. Estimate the probability that the next booking will be for 2 seats. How do you do it? I'll give 1 minute to think about it. Right, so estimate the probability that the next booking will be for 2 seats. So for 2 seats, what's the relative frequency here?
30 upon 8.
Yeah, so for B, we can say it's 30 upon 80, which is equal to how much?
30.
30 divided by 80 equals to 0.375, and we are going to write it as a percentage, right? So you can get the answer as 37.5%. This is the answer for B. So actually there are three ways you can give the answer. One is as a fraction here. So I have given all three methods here. So don't mix it up. You don't need to write all three. You can write the answer as a fraction and further simplify it as 3 upon 8. This is also correct. If you write it as a decimal here, this is also correct. If you further find it as a percentage like this is also correct. So all three forms of answers are accepted. Okay. Okay, so next question, it says, Maurice says that it is unlikely that a booking will be for less than 4 people. Is he correct? How you know it? They are asking you to explain it, right? What is your answer? Maurice says that it is unlikely that a booking will be for less than 4 people. Less than 4 people. So which ones are you going to take?
4, 6.
2,
3.
You can take anything less than 4. Anything less than 4. Is it clear? Right. So what are the numbers less than 4? 2 seats, 3 seats we can take. Can we take 4? No, because it already has 4. But they ask you less than 4. Right? So only these two we can take. Right. What are the two relative? Right. Let's take it here. C. How do you write it? Now which two we have to take? These two, right? Yeah. Total, in total how much?
40.
40 upon what's the total frequency? 80, right? This is equal to how much?
0.5.
Yes, 0.5, and if I write it as a percentage, I will get 50%. So from what we have learned, is 50% like unlikely?
No.
It is not, right? So is he correct to say that it's unlikely? No, he is not correct. So here 50% means we know it's even chance. 50-50. So you can get, it can be or cannot be, whatever it is, it's 50-50. So, but Maurice is saying it's unlikely. That means it's not, almost like it's not possible. So you can say 50%. So you can say incorrect because this is even chance. This is even chance. Is it clear?
Yes.
Alright, let's go to the next one. Okay, so for part D, The restaurant has approximately 240 bookings each month. How many of these would you expect to be for 4 seats? Now, how many seats are they looking for? 4 seats. 4 seats means this set of data only you have to take, right?
Yes.
And what's the relative frequency for that? 25 upon 80. Now they are telling you, using this relative frequency, you have to estimate how many it will be there for 4 seats if there are 240 bookings per month. So how do you do the calculation? For part D, it's going to be 25 upon 80 because that's the relative frequency for what?
4 seats.
Yes, 4 seats. So don't misunderstand and say that it's think that it's 80 multiplied by 240. The whole fraction needs to be multiplied by 240. So here let me write it again for those who will mix it up. It's like this: 25 upon 80 multiplied by 240. This is the approximate bookings they are expecting for a month, and this shows the relative frequency of booking booking 4 seats. So this is the value we took here, right? So for 240 there is going to be 3 times 80. So the answer is going to be 75. So you can say 75 bookings are expected to have 4 seats. Is it clear?
Yes.
Yes, you can. Okay, so moving on to question 6. An agricultural research center counted the bananas in 1000 bunches. So the number of bananas which has 200 to 219 in a bunch is 120. So 220 to 239 is 160. 240 to 259 is 200. 260 to 279 is 230. 280 to 299 it's 170. 300 to 319 is 120. Right. So altogether, if you add these frequencies to find the total frequency, what will be the answer? It's going to be 1000, because they have already mentioned it in the question that it's they have counted bananas in 1000 bunches, right? So total frequency here is 1000. Now what are they asking you to do is copy the table and calculate the relative frequencies as percentages, right? I will give you 1 minute to find the answers for this. You have to calculate the relative frequency and you have to write it as a percentage. For example, first one, 120 divided by, what's the total frequency? 1000. And how do you write it as a percentage? What's the percentage you got?
12%.
Did you get the answer?
I want it as a fraction.
Okay, so once you get it as a fraction, convert it into a percentage, because they ask you to find the relative frequencies as a percentage for each class year. Okay, so I'll give you 1 minute. Do the calculations. If you are written the answer as a fraction like in the previous cases, please convert them into the percentage and write the final answer here. Right, I hope the time given is enough to do the calculation. So tell me now, for the second group, what is the frequency you got?
16%.
So it's going to be 160 divided by 1000 equals to and yes, you can multiply it by 100 to find the percentage, and you're going to get the answer 16%. Similarly, for the third one, it's going to be 200 divided by 1000 multiplied by 100%. You get the answer as 20%. Here it's going to be 230 divided by 1000 multiplied by 100%, and the answer is 23%. Here it's 170 divided by 1000 multiplied by 100%. Answer is 17%. Yeah, I think they must have missed to put this one, right? Okay, so here it's going to be 120 divided by 1000 multiplied by how much? 100? No, yes, 100%, and the answer is 12%. Right. Let's answer the questions now. Estimate the probability that a bunch will contain 300 to 319 bananas. So we already found it. This is the answer. Yes. So already it's not given in that table there. You can see that place is already a blank. They have not asked you to calculate it, but in the question they are telling you to calculate the probability, so you can calculate it there, right?
Yes.
Now next question, who can tell me which set of data I have to consider for this? At least 260 bananas. So when it says at least 260,
It should be
which
given.
groups? At least means the lowest should be 260, right? So whatever comes afterwards will be calculated. So in this group it's 260, it's already there, so at least condition matches. These are anyway above that. So which three groups are we taking? These three, right?
Yes.
Now they are asking you probability that at least 260 will be there. So what are the three you are going to add here?
23% plus 17% plus 12%.
Yes. When you add these three, what is the answer you are going to get?
52%.
52%. So here to find the answer, what we did is take the first find which three groups you have to take. Which groups you have to take to meet the condition at least 260. So these three will be the three groups you have to consider here, and then take their relative frequency. So here it's 23%, 17% and 12%. Add all these three together and you will get the answer as 52%. Is it clear?
Yes.
Right. Now next one. Part C. A grower picks 5,000 bunches 1 week. How many of these would you expect to contain at least 260 bananas? At least 260 bananas. Now again a tricky part. I'll give you 1 minute to find the answer for this. Once again I'll explain. So these data given here is for 1000 bunches. So you already calculated the relative frequency for each group which has number of bananas here. Now they are going to tell you to find for 5,000 bunches, how many of these would you expect to contain 260 bananas at least? So again there is a condition you need to meet. I'll give 1 minute to find the answer. Okay, I hope the time is enough. Right, now for this one, with at least 260 bananas, we already found it's going to be 52. By 52%. How did we find it? We are going to add these three.
Yes.
Right, so I'll just write it here for C. you can just add 230 plus 170 plus 120. How much is it equal to?
520.
520, right? Now, how am I going to find the relative frequency for this? It's going to be 520 divided by 1000. That is for 1000 bunches. Okay, so I need to find the answer for 5000 bunches. Is it clear?
Yes.
This is going to give you the answer. Right, now again, for those who will mix it up with the calculation, let me explain. It's like this, 520 divided by 1000, because this is the frequency of getting at least 260 bananas out of 1000 bunches. If you want to find for 5000 using this relative frequency, what you have to do is multiply it by 5000. This is what I have done here. So here 1, here 5. So 520 times 5 equals to 2600. This is the answer. Okay, so question 7 now. It says the probability of not being connected when ringing a customer support service is 30%. So how do you write the probability? Not connected equals to 30%. This is something they have given in the question there, right? So whatever they tell in the question, just write it down on a side, because you don't need to go through the entire question over and over again. Let's say like 2-3 parts you have to answer, then you have to repeatedly read it and waste your time. So whatever the details, the key points, quickly write it down on a side and keep, so you don't need to read the whole thing. You can just refer to those shortened form, and then you can write the answers easily. Okay, so now I wrote the probability of not being connected, not connected, as 30%. On a typical Monday, customers ring the service 400 times. How many of these calls would you expect to be connected? Now they are telling, they have given you the probability of not being connected, and they are asking you to find for the customers how many of these calls will be connected. Find in the opposite. Now how do you find the connected one? Something you need to remember is this: probability of connected plus, let me write it a little bit smaller, probability of connected and probability of not connected. When you add them together, what will be the answer?
100?
No, it equals to 1. It equals to 1, right? All the outcomes will be in total, all the outcomes, if you add, it's going to end up as 1. So whatever, if you're finding a probability, probability is always going to be between 0 and 1, right? Then how do you find the probability of connected? Probability of connected is equal to 1 minus, I'm going to get this not connected part to the other side. So here the probability of not connected is 30%. Right?
Yes.
So what will be the answer? 1 minus 30% is going to be
70%.
70%. Sorry, probability of connected, right? Probability of connected is going to be 70%. Right, now we have found out the right, I hope you can see. Take it a little bit this side. Right. Now we have found out the probability of being connected. Now using this one, like in the previous question, you have to check for 400 times. Now if a customer rings the service 400 times, and if the probability of getting a call connected is 70%, how many of the calls you are expected to be connected? So to do it, you can just take it like this. 70% multiplied by 400. What is the answer going to be? 70% means 70 divided by 100. Right? Here it's going to be,
Zeros are getting cut.
altogether we cut the whole thing and put 4, no? Right? So what's the answer? 280. So we expect 280 calls to be connected if 400 calls were made. Is this clear?
Yes.
So this is the question we are discussing. This is the answer. This part I have given using the basics of the probabilities. Just as a revision, I am writing it here so you can refer to how I got this percentage and how I used it to calculate the connected calls of the 400 times they rang the service. Okay, now we are going to discuss question 8. An optician's records show that 21 of the last 50 customers bought designer frames and 14 of them bought 2 pairs of glasses. Estimate the probability that the next customer orders designer frames and 2 pairs of glasses. So for designer frames, I'll put DF. How many has taken designer frames? 21 out of 50 customers. So you can write this answer like this, or you can write it also as a percentage, 42%. This is for question 8, part A 1. Alright, 2 pairs of glasses. I'll write 2 pairs. 2 pairs, how many have bought 2 pairs? 14 upon 50. And what's going to be the percentage? It's going to be 28. Very good. 28%. Now using the relative frequencies we found here, they are asking us to find for the next 200 customers, how many would you expect to order 2 pairs of glasses? So which frequency should I use from these two? 2 pairs one. 2 pairs, right? 28%. So using 28%, which is 28 upon 100, I have to multiply this by 200. So here I can cut it. Here 2, here 1. Answer is 56 customers are expected to buy or order 2 pairs of glasses. Is that clear?
Yes.
Right, so for the discussion part, they're asking, is the probability of a customer ordering designer frames or 2 pairs of glasses? So O means one of the two, right? So you have to add both of them and see. Now they are as a percentage too. Both answers are as percentages here, the relative frequency. So add these two together, you get 70%. 70% is equal to 70 divided by 100, right? Now they are asking whether that is equal to 35 upon 50. Is it equal?
Yes.
Yes, if you divide both sides by 2, then you get this answer. So you can say it's yes. Okay, so question 9. Peter tested 10 batteries and found that 80% lasted more than 30 hours. Sven tested 100 of the same batteries and found out that 90% lasted more than 30 hours. Whose results are more useful? Peter tested only 10 batteries, but Sven tested 100 batteries of the same kind. See, there's a key point here. The more data you have, the more confident you can be about any conclusions based on the data. So, taking this to your head, whose one you are going to use it? Use to find which one, whose result you are going to use it. Sven's. Why? Because he used 100. So if you have used more data, means you have more confidence, because using more data they have found these values. But out of 10, you can see even the answers have changed a little bit. But actually, if you see, Sven's test shows much accurate data compared to Peter's. So Sven's will be the answer. Okay? Right. Okay, let's go to the next question. Question 10. It's a problem solving reasoning question. Edward asked, this is 10A. Edward asked 20 people which charity they donate money to. 11 said Oxfam. Estimate the probability that a person donates money to Oxfam. So how do you find the relative frequency here? How many people altogether? 20. Out of 20, how many are giving for Oxfam? 11. You can write it like this, or you can write it as a percentage also, which is going to be 55%. So you see this sorry about that. So this lesson has not only probability but also part of percentages where you need to do some calculations.
Yeah.
Right? Okay, so next part B. Odwell asked 80 people which charity they donate money to. 45 said Oxfam. Use his data to estimate the probability that a person donates money to Oxfam. So without telling, estimate the probability that a person donates money to Oxfam, they tell you something else. Use his data to estimate the probability that a person donates money to Oxfam. Yeah? Small changes but the same thing you need to do. So how do you do it? 45 said they are giving to Oxfam out of
8.
total of 80. What is the value? You can write it as a percentage. Anyone who can give me the answer? It's going to be 56.25%. 56.25%. Now these two are two people, right? And they have asked from two different groups of people. Two different groups mean two different number of people in each group, right? The first one asked about from 20 people, but the second one asked from 80 people. Now in part C they are telling you which estimate do you think is more reliable? Give a reason for your answer. So which one you are preferring?
Odwell.
Odwell's. Why?
Because he has more data.
Because he has asked from 80 people, so it gives you the confidence to make your conclusions based on this data. So the more data you have, more confident you are, right? You can write your answer in your own words. So answer is Odwell because he uses 80 people to find out the relative percentage. Alright, so next one. Edward and Odwell shared their data. Use their combined data to estimate the probability that a person donates money to Oxfam. Right, so altogether, how many people in total?
56. 100.
100. 20 plus 80, it's going to be 100. Out of 100, how many people have told they will give to they will donate to Oxfam? 45 plus 11,
56.
right? So it's going to be 56. So using their combined data, estimate the probability. You can write it as a fraction percentage, 56%. Or you can write it as a fraction, or you can write it as a decimal also. If you write it as a decimal, it will be 0.56. Alright?
Yeah.
Okay, now question part 2. In that, they interview another 200 people. Now for 100 people only you got 56%, right? So for 200 people, how are you going to do it? 56 upon 100 multiply by
200.
multiply that by 200.
112.
So you have 2 here, you have 100 here. It's going to be the answer.
112.
112 people are going to or expected to donate money to Oxfam. Are these clear to you all?
Yes.
Clear. Okay, right. So question 11 and 12 you can just go through and see if you can find your answers. But up to 10 are the questions that we wanted to discuss for this lesson. For the next session, in the checkup questions, since we have completed both lessons for this unit, we can discuss experimental probability question 1, question 2, question 3, and then estimating probability question 4, question 5, question 6, and let's see how many of you can do the challenge question. So if you're doing the challenge question, you are allowed to use a calculator. Let's see if anyone is clever enough to solve it out with the correct answers. And also in strengthen, we can take question 1 in experimental probability. So always refer to the hints given in for each question. So here it's question 1b. So for this they are giving you a hint. So go through it. It will help you to solve it out. Solve the question easily. So then question 2. Then question 2, there are some other parts, part B and C here. And then question 3. So question 3, there are some hints given there with some formulas. You can use these to find the answers. Then question 4. And for estimating probability question 1, question 2, question 3, 4 and 5, and try and see if you can find the answers to enrichment questions as well. Moving on to the extent where you will get a mix up of different types of questions. So here you can mark question 1, question 2 allowed with a calculator. So you can you have to write the probabilities for part B as percentages, so you are allowed to use a calculator here. Question C also you can use a calculator. Some of the literacy hints are given there. If you are not familiar with these terms, they have mentioned what it is. Question 4, question 5 and question 6. Then question 7, question 8. Again, some hints are given there, you can use them, and question 9. So if you can just try to do these questions and come, we will be discussing the answers and explaining how to do this. See you next time.